Welcome to this comprehensive 2026 deep dive into modern software architecture patterns. We are living in an era where system complexity has exploded, but so has our capability to manage it. Today, we are going to explore the three pillars shaping our digital future. These pillars are event-driven architecture, serverless computing, and micro frontends. Together, they enable us to build systems that are not just scalable and resilient, but inherently AI-ready and capable of adapting to real-time demands. Why is architecture evolving so rapidly? It's the sheer volume of data. In 2026, we aren't just processing batch data. We are handling petabytes of real-time streams from IoT devices, edge sensors, and user interactions. Coupled with massive AI inference workloads, the old monolithic ways simply cannot cope. Looking back, we moved from the rigid monoliths of 2015 to the distributed microservices of 2020. But even microservices faced bottlenecks with synchronous HTTP calls. Now, we've evolved into a fully asynchronous, event-driven serverless mesh that decouples computation from state entirely. Let's go deep into event-driven architecture, or EDA. At its core, it's about shifting from command and control to react and respond. Services don't ask each other to do things. They publish facts about what just happened. This inversion of control is powerful. This architecture allows for massive scalability. You can have hundreds of distinct services listening to the same order-placed event. The inventory service reserves stock, the AI service updates recommendations, and the shipping service schedules a drone, all reading from the same immutable log at their own pace. Moving to serverless computing. It's often misunderstood as just FOSS, but in 2026, it's an operational model. It means zero idle capacity. You literally pay nothing when no one is using your app. This creates a powerful economic incentive for efficient code. Serverless is the engine of AI. When a user uploads an image, a function spins up, loads a quantized model, runs inference, and shuts down in milliseconds. Attempting to maintain always-on GPU clusters for bursty traffic would be prohibitively expensive. Serverless solves this. Now, let's talk about the front end. Micro frontends apply the same decoupling principles to the UI. We use module federation to dynamically load bundles at runtime. The checkout team deploys their code, and the main application consumes it instantly without a full rebuild. The real value here is organizational. It eliminates the front-end monolith bottleneck. Autonomous squads can own a vertical slice of the product, from the database all the way to the pixel on the screen, deploying daily without fear of breaking the homepage. Integrating these three is where the magic happens. Your micro frontend emits a click event. That event travels via WebSockets to an event gateway. The gateway pushes it to Kafka. A serverless function consumes it, updates a state store, and triggers a side effect. But complexity brings challenges. You need robust observability. Distributed tracing is mandatory. You must design for idempotency because events will be delivered more than once. And you need strict schema governance to prevent breaking changes downstream. Mastering these patterns is the key to building the next generation of software. It's about embracing asynchrony, optimizing for value, and enabling speed at scale. Thank you for joining this deep dive.